Well, hello everyone. I'm Josh with DNS Filter. I'm so glad that you guys could join us today. And we're just going to talk on a very basic subject, just how DNS filtering works. So it's a very accessible introduction, this webinar today. Just go over some basic concepts. And if you have any further questions, then don't hesitate to ask. So let's go ahead and get started here. This is the roadmap for what we're going to be talking about this afternoon. We're just going to, again, go over the introduction to the DNS protocol and a little bit about recursive resolvers. And then we're going to go ahead and go over DNS for security and then some unique advantages that DNS-based filtering brings over other platforms for security, and then a few use cases. All right, so first, what is the DNS system? Really, as an overview, it's a hierarchical database that provides answers for DNS requests. And it's the prerequisite for almost all online communication, regardless of device or platform. And the example I like to use all the time is that it's like a phone book. And I also love the television show Mad Men. So my example here is if you were to look in the phone book for the address for Don Draper, you would look in the phone book and you would see that he is at 42 Bullet Park Road. And it's basically the same way that the DNS system operates. So just like the phone book, you're going to be looking for an address like www.facebook.com. You type that into your web browser and a IP address comes back. So this translates human readable host names like facebook.com into IP addresses, which are machine readable. So I can't overstate this enough. DNS is a cornerstone technology for the internet. Anything that needs to will invariably use DNS. And the only exception to this is when something is making a direct IP connection and already knows about that. So in the scope of things, that type of communication is pretty rare. So I'm going to just do a brief overview of the DNS system. It's actually really interesting. So it actually evolved, just like the internet evolved from ARPANET in the 1970s. The DNS system, the precursor to it was actually a single host.txt file on a single computer in Menlo Park, California. And that computer was the authoritative source for all of the host names that were on the ARPANET. And so people would come in, they would FTP into that server, and they would download that file as that authoritative answer for everything. But as you can imagine, the network quickly grew into a larger than manageable entity at that stage. People would have to phone in their updates, and all of that during business hours. And so it quickly became very unwieldy. And a guy named Paul Makapetris was in charge of coming up with a solution to this. And he evaluated several proposals, but he ended up scrapping them and writing his own. And the result is the DNS system, in large part, the same conceptual system that we use today. So I think it's good to just look at the name in comparison to how this works. So what's in the name? So the DNS system operates on what are called fully qualified domain names, and you can see that in the slide here. So typically, you say you type in your web browser, you'll have a protocol, could be HTTPS, HTTP. If you're outside of your browser or using something else, could be FTP, things like that. But the FQDN is listed here on this slide. So the way to read this is actually in reverse. It's actually to go right to left. So you start at what's called the root, which is indicated by and this is invisible to you usually when you're using your web browser. You don't see it, but it is technically the anchor or the root of the FQDN system. And it's represented as the top level in this database. There's actually 11 authoritative root name servers that answer to this. And then again, we're going right to left. So the second is the top level domain. This could be, .com, .org, .net, etc. All of the country level TLDs, they all fall into this. and then it will be a second level domain. So that's typically what people will purchase when they go into Namecheap or GoDaddy and they purchase a domain name. They're purchasing, dnsfilter.com or, yourbusiness.com. And so this is hierarchical, so you can see the root and then the top level and the second level. So I'm just kind of showing this here. We'll talk a little bit more about this in some following slides here. So a good way to look at this is the life of a DNS query. So when you type in google.com into your web browser, these are the steps that take place in the DNS system. So the first thing that happens is that your browser performs a cache check on itself and a cache check on the operating system level of the machine. So it first asks the question, hey, I'm asking for google.com, but maybe I've already asked that, 10 minutes ago, and I already know the answer. So it can respond immediately. The second thing that happens is it will hand off the request to whatever the recursive resolver is that's designated there. So it could be Google's name servers or ourselves, DNS Filter. And once that request gets handed off, the recursive resolver is responsible for answering it. So behind the scenes, it actually goes and sends a series of requests. So it first asks the root name server, that dot that we talked about earlier, says, hey, do you know about the .com servers? And the root server says, yes, you need to go here. And then it says, okay, I'll go to the .com server, the top level server, and say, do you know about Google? And I'll say, yes, I know about Google. Here's the answer. And then it will ask the second level, do you know, it's asking Google at this point, do you know about your www.subdomain? And then it will respond and say, yes, I do. So it finally takes this answer back and replies back to your host, your computer. The cool thing about this system is that it's authoritative. Because you've asked at every level the people that are supposed to know the answer, you have an authoritative answer for that request. If it doesn't exist, it will reply with one of three different, basically non-existent requests, something like an NX domain, or it says that domain doesn't exist. And then your computer at that point will give up. It will say, okay, this domain doesn't exist and I won't try to find it anymore. Let's go ahead and talk about DNS from a security standpoint. So DNS is a very effective layer of security, and there's a couple of reasons why. The first is that it protects all of your network devices. So this is printers, laptops, tablets, anything that's internet connected. So it could be your alarms, your refrigerators, your toaster if it's connected to the internet. It doesn't matter. If it has the capability to connect to the internet, because DNS is such a cornerstone technology, it will use DNS invariably to connect to the internet. And so this is at a point where if you're using something like DNS Filter, you will have coverage completely over your network, regardless of operating system or things like that. It's very effective. The next thing is that it's effective because it actively prevents a connection to internet threats. And so you can see from this diagram here, there's a few different devices that are connecting to different applications on the internet, things like Facebook, Dropbox, and then you have a tablet down here that's trying to connect to some malicious domains. These attempted connections first go through the DNS resolver. And so a security-focused resolver can terminate that connection to a malicious party before it even reaches them. So this malicious party on the right side of the diagram is unaware that that connection attempt was taking place because it first had to go to the resolver. This is huge in the security world because it means the malevolent source is unaware of what's happening. They have no idea that this connection attempt was being made. It happened at a level where at the DNS level it's perfect because that is one of the first transactions that takes place from a network standpoint. So it's a wonderful layer to target in terms of security. It's also kind of tied in with this. If you brought an infected machine onto the network, on your network, and it's attempted to communicate and phone home, again, that DNS resolution takes place, and it's prevented by the resolver. Now, in terms of advantages that only the DNS layer can help with, there's a few things here. One is that a DNS-based filter is very easily deployed. So often it's as simple as one settings change. You can change your Active Directory forwarders. You can change your router or modem settings to set upstream DNS to something like DNS Filter. And after that, you can manage everything remotely. So it's very easy to turn on. The second thing is that there aren't any updates necessary. So if you use a cloud-hosted solution, you're always protected against the latest threats, and any changes that are made on the vendor side are immediately propagated, and you're able to take advantage of that. So you're, contrary, now we wouldn't say that we are a replacement for an antivirus, but in terms of how it operates differently, and an antivirus application, that host application on the machine, first of all, they have to cover that machine. So things like mobile platforms, they don't have as good antivirus coverage, but those database updates have to be on that machine in order for it to be fully protected. Whereas when you have something like DNS Filter, those updates are on the server side, on the infrastructure provider side, and not on your side, so you don't have to worry about that. The last thing is that it works within your existing infrastructure. So you don't have to make any changes. You don't have to install any hardware appliances or anything like that. It's something that's very common, and you're able to take advantage of that across environments. So I don't want to turn this too much into a sales thing, but I will slide in terms of us as DNS Filter. So one thing is that we have an Anycast network that is one of the fastest global filtering networks. We alternate between #1 and #2, actually the last couple of weeks. Our response time is about 22 milliseconds, which is insanely fast. Google's response time in their 8.8.8 is 30 milliseconds. And so 22 milliseconds, we got 8 millisecond response time faster of a filtered DNS request versus just a stock answer. So that's wonderful, and we're working on becoming #1 as well. The second is our AI categorization. So we actually have an AI scanner as part of our solution. It's trained to recognize and classify web pages, and it crawls millions of domains per day. We also have anti-phishing component to that. So scans web pages for Dropbox logins, Office login, Google logins, things like that, and actually will cross-check to make sure they're on the domain they're supposed to be. Otherwise, it's flagged as a phishing domain. And then the third thing is our real-time filtering. So this is pretty unique in the industry. There's only one or two other people that have something like this. Basically, that DNS request, that life of a request that we talked about earlier, as part of that, what we will do is actually, if a domain has never been classified by us at all, if it's unknown and unseen, we will first take that and we will classify it on our end before returning a result. So that often that is a sticking point with a lot of solutions, because how you treat unknown domains, you can either block all of them or allow all of them, but it's one of the biggest areas for security and one of the biggest gray areas. What do you do with an unclassified domain? And so that's how we handle it. And so last, we'll talk about a few use cases here. And we definitely have plenty of time for questions. It looks like we're at about 15 minutes or so here for the webinar. So I just want to talk a little bit about transportation and public Wi-Fi, because this is a great use case for DNS filtering in general. When people, there's a few unique challenges in this scenario. One is that people often use public internet when they're engaging in illegal and unethical activity, right? They're thinking, I'm not going to go search for this at my house. I'm going to have police knocking at my door. So I'm going to go to a public Wi-Fi hotspot somewhere and engage in whatever activity I want to engage in. So that's a challenge. The second thing is you don't have endpoint control over those devices. So Imagine you're a coffee shop or you're a public transportation provider. You can't ask people to install a filtering app on their phones or on their laptops. You don't have endpoint control like that. So that's one thing that's a challenge. The third thing is people kind of take it for granted. They strongly desire to have public Wi-Fi. If they're at your restaurant, they're at your it's an expectation these days that you're going to provide public Wi-Fi. So it's not something that you can just decide, well, I don't want to do it. It's going to kind of, you're going to suffer for that. So the reason DNS filtering is superior in this environment is because it addresses all of those challenges. You don't need to alter the end user's device in order to do filtering. You don't have to break privacy like you would at another layer. DNS requests start an internet transaction, but they don't log what occurs during that transaction. So, things like passwords or things like that, they don't traverse over the DNS network. So you don't have to worry about things like that. It's also very lightweight and just very quick in general. With involving no changes to your existing infrastructure. And the cool thing is you don't break any privacy, but you're able to enhance the visibility of how your network is being used. So you're able to aggregate data and say, okay, a lot of people are trying to visit Netflix while they're on the network. A lot of people are trying to visit Facebook, things like that. And you're able to shape some traffic that way. So if you wanted to save bandwidth, you could block sites like that. So people are allowed to access other internet domains, but they're not allowed to do streaming websites. So you're allowed to still have a lot of control over what takes place on your network at that level. And that is it. Thank you for watching this introduction. I will be here, Josh, as well as Brian Patterson is on here as well. So if you have any questions, we can definitely answer those right now. Let me address Ricky's question here. There will definitely be a copy of this somewhere. So if you've registered for this webinar, you will be able to get a copy of this recording. All right, Tim asked about MacBooks. And yes, we're happy to report actually our staff is, a lot of our developers run Macs, and I'm running one right now, and we're actually running the application. It's probably about, it's very close. I'd say probably about a week or two. We're very close to releasing it. It works, it's very stable. We're just making some UI enhancements to make it look very nice. And yeah, it's definitely very good for roaming. So the way that we have it right now is actually, it's basically a PKG file for Macs, which is a pretty standard method of deployment. I personally am not sure in terms of the enterprise level. I know our Windows user agent can be deployed via Active Directory group policy, but Macs, I assume there's a broader level way to do that as well. Let's see, Will asks, if the end user gets stuck in a captive portal, can the end user disable the filter until they get online? And we've actually designed it to work with captive portals. So I think you're still presented with it, but you're able to, it's still handled by the app. Tim's asking, do we have any configuration on that PKG once it is installed? So there is a configuration file. The one thing that the app asks is for the site secret key. I don't know, Tim, if you have any experience with the DNS, the Windows version of our DNS client, where it asks for the site secret key. You also have the alternative to deploy via command line flags if you want to incorporate that as part of your installation script. And so I assume we're going to do something pretty similar with the Mac OS agent, where you can deploy it and send in that key along with it. All right, so Brian was getting at me to explain a little bit how the agents work. I think that'd be kind of helpful here. So the way that all of our agents work, and actually we have a forthcoming LAN proxy as well, is that they run a local binding to the DNS traffic that takes place on your adapter. So what happens is first, your DNS requests go to the agent, and the agent makes the determination intelligently, is this a local query and it just needs to be handled locally, or does it need to get sent out to DNS filter servers for resolution? So it's very smart. Anything that's already local address, recognizes as a local domain, is automatically handled. So that's how you're able to deploy it, and it works within your Active Directory infrastructure with no modification. So you'll still communicate with local resources for that standpoint, and then everything else will get resolved via the internet side. In terms of the cost of the agent, Tim's asking about that. Right now, we don't have any additional costs for the agent, so that's a really big selling point. That site secret key that I mentioned earlier is a way to identify the agent with a particular location that we already have, a physical deployment. And so what happens is the queries from the agent get counted along with the queries from that location. So they're all lumped together. So from a billing standpoint, it's just viewed as a connection mechanism. There's no additional fees for it. And then also I hinted at the LAN proxy, which operates basically the same way. You'll have one computer running on your network that will be the place that you're sending queries, and then it can send them onward into, say, your domain controllers or send them out to the internet. The flexibility of that is that you're able to look inside your network and see where certain queries are coming from. You're able to target network subnets in a different way as before. So you're able to look in a little bit deeper in terms of seeing your traffic. Hello, Roger. Welcome. So Tim, the cost, really right now we have two options. So one is if you are an MSP or you have a larger organization, you can do $1 per user per month. The other thing that you can do is by usage. So it's basically $1 for every 200,000 queries, which roughly is about 2 people a month. And I should explain that a little bit. So we have a minimum where it's $5 a month per network. So that's it basically covers like a 5-user network for the month. Yeah, we can definitely cover you, James, and I think Brian's about to answer here, but
Oh, yeah. So, James, we have, well, each public IP address would be considered a network. And we also have usage-based pricing. So in that case, you would just get charged for however number of requests come through. And that's a $1 per 200,000 requests. And that can vary depending on your usage. So if you have 1 month with a lot more users, you'd get charged a little more or less depending on that. And then it would always be that $5 minimum per public IP address that we see. And I'll ask Josh for we often get questions about enforcing different policies. So how are you able to enforce different policies for different users within the same network?
yeah, we definitely have a pretty unique feature actually with what are called NAT IPs. So we can have actually 7 different policies on the same network. And the way that that's handled is that you actually have a different DHCP handout typically for the DNS servers. So on subnet 1, your guest Wi-Fi network, you will hand out different resolver IPs that are pointed to DNS filter than you would for a different subnet. And then we'll actually handle it on our end. You can configure a policy that's separate. So a lot of people use that for guest Wi-Fi if they have it on their same internet pipe.
Yeah, and I think, James, the question you just asked there about the different levels of filtering, that's kind of just what we went over there. You can do that with the NAT IPs. So in your case, since you're talking about a library, you might have the guest Wi-Fi have one policy, and then the like staff network have another policy. And there's also the ability to have a bypass password in there, so that you could give that to the librarians to be able to bypass the filter for certain sites that would be allowed. And there's also the ability to add things to a whitelist, so that if there are legitimate sites that you want to be able to get past in certain categories, you can do that. Looks like James is working on typing something new.
We definitely have a lot of libraries in schools too, James, so you're in good company. Hello, Tim. Yeah, we're not really channel only right now. We sell channel as well as direct. But we are making some changes to how we do things with MSPs. I think it's going to be pretty exciting. We're just going to make it a lot more beneficial to be an MSP with us.
Yeah, and following up on that as well, a lot of the kind of customers that you would have, they wouldn't necessarily be reaching out to us anyway. They would be they generally don't understand how the DNS filtering works and how it can how they are able to set it up, in which case we would refer them to an MSP to be able to set that up. And James also asks, could this possibly replace Barracuda security appliance? Josh, you want to take that?
Yeah, it depends what you use it for, especially in terms of the roaming application. Then we're a lot better at that, actually. So the problem you're going to face with an on-site hardware appliance is that when you have somebody that's roaming, okay, I answer the question. I'll just finish it just in case anyone else wants to hear that. But people that are roaming, say they're getting off, your home office is in the US, they get off in London or wherever. You don't want them to have to VPN back just to get the filtering aspect of things. That's going to add a lot of latency for them. So the benefit is that with us, you're actually always hitting the nearest geographic node to where you are. And that happens automatically through Anycast routing. So there's one benefit there versus having a hardware appliance like that. Now, what we don't replace, at least currently, and we are kind of examining long-term with this a little bit, but we don't replace the layer 7 deep packet inspection component. So we don't handle that, and that's something that a hardware appliance does usually very well. So it may depend, the answer for that could depend on your organizational requirements. And then I'll circle back and answer Tim's question here in terms of the prices. We do have standard pricing that's really the same right now. So that's kind of what it's hinting at with the MSPs. We're going to change it so there's more of a price break to be an MSP. Pricing is, so that will help to guide people in that direction as well. We're also one of the only vendors in the marketplace that actually white labels our product fully. So we can resell to you our solution as being completely white labeled, and your customers have no idea that it comes from us. So it's just a really clean part of your solution stack. We also make our marketing materials available, white labeled as well, so we can help you to do pre-sales engagement with customers and things like that. So we really are on your side in terms of reselling our service. And we just set up a poll too. So if you check on the polls tab, if you just want to answer real quick, if you're an MSP or not, that will just kind of help us with evaluating the webinar as well. Looks like a lot of you guys are MSPs actually. Me. Just asked a follow-up question to that. If you guys want to answer a little bit of what your RMM platform that you use is. We're a little bit more curious about that this year in terms of looking at different integrations and whether that would be something that you guys would really benefit from. So say right now for Lab Tech was part of ConnectWise and also Kaseya, we actually have customers that have used that have written scripts already for the agent deployment. But we are looking just kind of in the future at other things that we can do. Looks like a couple of you guys answered other. If you just want to paste in chat what the name of that is, I'd love to research that a little bit more for you guys. Okay, log me in, says Paul. Okay, Synchro. Yeah, we just met them. We just went to Robin Robbins a couple weeks ago, and we were meeting with some other vendors there too. And I think Synchro was there. Data was obviously there. Okay, thank you, Tim. That's helpful. Well, it's 1:38 here, so I'll be respectful of everyone's time. Thanks for watching. If you guys have any other questions, don't hesitate to reach out to us. I think we pride ourselves in being pretty approachable. So reach out to Brian or myself. If you send anything to sales@dnsfilter.com, that's a really good way to reach us, and we can get back to you. So again, yeah, thank you so much, and look forward to seeing you guys in the future. All right, bye.